Mars' core looks bigger than it is because it's wrapped in radioactive magma. Data from a meteorite impact on Mars that was recorded by NASA's InSight lander in 2021 is now helping to clear up some confusion about the red planet's interior makeup. A pair of studies published recently in the journal Nature separately determined that Mars' iron-rich core is smaller and denser than previous measurements suggested, and it's surrounded by molten rock. The now-defunct InSight lander, which arrived on Mars in November 2018, spent 4 years recording seismic waves produced by Mars quakes so scientists could get a better understanding of what's going on beneath the planet's surface. But estimates of the Martian core based on InSight's initial readings from nearby quakes didn't quite add up. At the time, scientists found the core's radius to be somewhere between 1,118 and 1,149 miles, much larger than expected, and that it contained a perplexingly high amount of lighter elements complementing its heavy liquid iron. The numbers for those light elements were bordering on the impossible, said Dongyang Wang of ETH Zurich, a co-author of one of the studies. "We've been wondering about this result ever since." Then, a breakthrough came when a meteorite struck Mars in September 2021 all the way across the planet from where InSight is positioned, generating seismic waves that ETH Zurich doctoral student Cecilia Duran said allowed us to illuminate the core. Based on those measurements, the two teams have found that Mars' core more likely has a radius of about 1,013 to 1,060 miles. This, the ETH Zurich team notes, is about half the radius of Mars itself. A smaller core would also be more dense, meaning the previously inexplicable abundance of light elements may actually exist in smaller, more reasonable amounts. This is all surrounded by a layer of molten silicates about 90 miles thick, the teams found, which skewed the initial estimates, and it's unlike anything found in Earth's interior. According to Vedran Lekic from University of Maryland, a co-author of the second paper, the layer serves as somewhat of a heating blanket for the core that concentrates radioactive elements. Studying it could help scientists uncover answers about Mars' formation and its lack of an active magnetic field. Thanks for listening to the show. Make sure to rate, review, and subscribe on Apple Podcasts. Today's show featured journalism by Engadget contributor Cheyenne McDonald and was produced by Spoken Layer. I'm Imran Sheikh, and we'll talk more tomorrow.
Spoken Layer.